Hi.
Welcome back, everybody. This is Jim Grisanzio coming to you live from Singapore at Oracle OpenWorld and Oracle Code. And I'm here with Wim Coekaerts.
Hi.
Wim, nice to
Good
see you again.
Yeah.
At every conference I go to, if Wim is there, I grab him for an interview because we talk about developers, we talk about Linux. Now, Wim, I was in your keynote a little bit earlier today, and one of the things you said is that developers really matter. And so let's start off with there. Why do developers matter?
Well, I mean, obviously they've always mattered, but I think, in the past, on premises, in our sort of previous part of the business, it was you have sysadmins, you have developers, you have application developers that write stuff for customers. Now the developers and the sysadmins have kind of merged, the DevOps model, so they're a little bit more on the front line. And so for companies like Oracle and certainly in general cloud vendors, we need to be closer to developers than ever before. We have a huge developer ecosystem with Oracle Database and WebLogic and Java, but they're now getting closer to the cloud deployment model. They're the ones that create the instances, not just write applications that live on top. And so what we've been working on is to make sure that the DevOps model of being able to create infrastructure using code, to write the application using code and do like end-to-end automation of all these things. So it kind of changes the relationship. And so we put a lot of effort into that.
So with the migration, with everything going to the cloud, in terms of the developer engagement, has that changed over the years most recently?
It has, because the developer's a little bit different now. Right, so like I said, it's no longer just an application developer that uses a language, let's say Java or Go, and then writes an application, ships it to a customer, deploys it. Now, they also do the deployment of infrastructure, and so you're dealing with a developer that's now sort of multiple personas. And traditionally, like you have an Oracle DBA, you have a sysadmin, you have a hardware admin. Now that's all blended. And so when you talk to a individual developer, you're really talking to 3-4 different personas. And what we need to learn is to not keep separating them. We need to provide them with the tools and the SDKs and libraries where they can do all these things at the same time, rather than saying, oh, you can do this here, you can do that there, you can do that there. It's like, no, we want to do all of these things together, right? And that's what we need to do more of.
Interesting. Okay. Now, specifically about Linux, I noticed a couple of things that you said in the keynote that were very interesting to me. You talked a little bit about Ksplice in terms of the ability to patch a live kernel, and also in user space as well. And this was unique. You said this was unique to Oracle. Mm-hmm. Can you talk a little bit about Ksplice? Sure.
So Ksplice is something we introduced about 9 years ago now, and by itself, initially it was it is a technology that allows us to create patches that you can apply to a running kernel. So you have a Linux kernel, there's a security vulnerability or a critical bug fix, and we can provide a customer with a really small piece of code that they can insert into the kernel while their applications are running, while the OS is running, and they don't see any downtime. It's literally 8 microseconds of a hang.
So no real noticeability.
No. You can run an Oracle database and we can patch the database while it's running, and you just don't notice it. Of course, all the benefits that come along with this from a system availability point of view. Now, what we also added a few years ago is the ability to patch user space libraries. User space. And as I mentioned in my keynote, strangely enough, user space is actually much more difficult, because with the kernel, there's one monolithic thing running. You can lock it, you lock the whole system for microseconds, apply the fix and continue. When you're in user space, a single library file like libc can be opened by thousands of processes. They each have their local memory, they each have potentially different things going on. And so when you patch that library in memory, you have to coordinate all of this. You have to coordinate the on-disk library because a new process will use the new version. You have to coordinate all these processes in user space. You can't lock everything at the same time. So it's a lot more complex to do. But the benefits are great, because what we can patch is OpenSSL, glibc, and QEMU. OpenSSL obviously important because everything that does encryption, like with Heartbleed, Apache applications running HTTPS would be using this library. And so if there is a serious vulnerability, you have to apply the patch, restart all your applications. And typically that means a reboot of the system, and that's very expensive. And so we can apply it online. Just like with the kernel, you don't notice it continues.
What about the distinctions about, applying these patches at scale? I mean, versus, a very small number of computers versus thousands of servers.
So there's two parts to the K-Splice advantage, and certainly something that's really unique to Oracle. And so the first one is that it's one thing to provide a patch to the customer, it's another to be able to have the internal infrastructure to say there are, let's say, 4,000 different kernel versions, right? Because you can run Oracle Linux 7 from 2 years ago, and you never rebooted your system, so you run a kernel from then. Or you could be up to date with last August's kernel, or up to date with last week's kernel.
Right.
So when this bug fix gets released, we actually have the ability to go back 2-3 years and build it for every single update that was released. So from a customer point of view, it doesn't matter where you are, we can give you a patch. So the system of being able to automate backporting these patches to these different kernels and build them is really unique. Building the patches and the complexity of each of these patches also, there's a lot of experience that we've had over so many years, but the actual backend of building 4,000 versions of a patch, that's not something anybody else can do. And so we're very proud of that, and it helps the customer because it gives them choice, right? And so we can do that. You can run a kernel for 2 years ago, we apply online updates, and it's all good.
So this ability to patch live systems at scale seems to be very, very important right now for a whole bunch of security reasons. We've had a lot of very, interestingly named, security vulnerabilities recently, in the Linux community.
Right.
Can you talk a little bit about the, how Oracle Linux deals with those security issues?
Yeah, the most recent complex one is the Spectre Meltdown set of patches for the CPU vulnerabilities last year. And to give you an example, one of those patch sets was 105 patches. So we had to apply synchronously, basically, 105 kernel patches onto a running system.
Is that a large number of patches?
That's a large number.
It is.
Because when other, and I'm just going to say, when other competitors talk about live patching, they can patch like one line of code. We had 105 patches across the kernel.
Now, how many lines of code would that be?
Oh, many hundreds.
Hundreds.
Yeah, many hundreds.
But it's touching larger.
Yeah,
it's touching the whole kernel.
Spectre Meltdown touched many areas in the kernel because it was basically protecting certain pieces, and so it was a very, very complex set of patches. But we pulled it off. So that was a challenge for the team. So that's one part. The other part is, when you have a system that's patched and somebody gets into it and tries to find a hole, then if it's patched well, you don't know that they're trying to abuse it because there's no sign of it. And so one of the things we started doing very recently is when there's a unique signature for a vulnerability, then with these K-Splice patches, we add that signature detection into the kernel patch so that if somebody's trying to abuse it, we will actually create an audit record. And on the system we'll say CVE number, process ID, process name was trying to use this vulnerability. And so from a sysadmin point of view, if you have a set of servers, whether it's in the cloud or on-premise, doesn't really matter. You can actually say, oh, somebody is trying to abuse this system or this set of systems. And so you can isolate where a potential intruder is trying to abuse the system and proactively get them off the system. You can isolate it and shut it down and then see what else is happening. Because otherwise they can be around for months. Right. And you just don't know.
So that ability to do that, is that unique?
Very unique.
Really?
Yeah. Yeah, it's something we started working on quite a while ago. And doing the signature detection by itself it's not easy, but it's code. the complexity and why it took us a while to get this released is that we have to make sure that this cannot be a denial of service. Right? If somebody tries to abuse that thing a million times a second, right, then the system crashes. So we don't want to introduce denial of service issues in our code, and so that took some time to figure out. Yeah.
Interesting. Okay, well that's good news.
Yeah.
Now, in terms of your organization, you're working with the engineers at Oracle as well as the community as well as Linux community.
Mm-hmm.
There's certainly a blending there because you guys are contributing to the main Linux community. Where does Oracle sort of fit in terms of the meta general contributors to the Linux kernel?
So it kind of, it depends on how you look at it, right? So what sometimes happens is there's this Linux kernel weather report, which is very good. Jonathan Corbet and folks do this. And so what they do is they take a Linux kernel snapshot, let's say 4.16, and then they look at all the patches that were submitted upstream. And they look at who contributed that patch, and then they say vendor A 3%, vendor B 5%, and so forth. And so that's how they sort of look at who contributed to that kernel. Now, it's a point in time. And so most developers, when their bug fixes happen on an ongoing basis, right? But when you write a driver or a file system or a big feature, that's not something you do for, in a month. And for one kernel, it can take 6 months, a year, or longer. And so when that piece of code gets accepted by Linux and goes into kernel, then suddenly there's a large chunk being contributed. And so as a company, customers do look at this ranking and say, oh, look, this is Oracle's number 6, and vendor whatever, so why are you lower than them, or why are you higher than them? And so it kind of depends on which kernel version. And so what we typically do is say, look, over the last year, look at all the kernel versions, for instance, 4.16 to 5.0, and then if you look at it over a period of time rather than an individual kernel version, then the statistics change a little bit.
Right.
So it's not about number games, because we're very consistent in contributing. But if you do look at the last year, we're number 3. Right, and so that's quite good. Whether it's bug fixes or new features, and it's across the kernel. Whether it's file systems, memory management, security, KVM stuff, and stuff. So it's across the board, and so we're pretty good. It's not competition,
right?
But
right.
it's we want to make sure that customers and users and developers see that we're contributing and not just shipping code.
Right, exactly. Or just shipping, right.
Yeah.
Now, in terms of the system that we actually ship, one of the things you mentioned in your keynote is, in terms of you always ship the latest in the tools and the libraries for developers, but the platform is stable. What's the distinction?
So what I talked about at the code keynote was that developers typically like to use the latest version of libraries and languages and so forth, because they want to use the new features. From a production deployment point of view, you want stability. Right? You don't want a new version of a library to break the application that was running for 4 years. And so there's this constant battle between providing a production platform that has stability over a number of years with a developer platform where they just use latest and greatest. And so what we've been working on a lot is finding that balance between OL is stable. Oracle Linux 7 is now about 4 years old. When you look on the system, the libraries are literally, the base versions are about 4 years old. They were frozen in time. Doesn't mean we don't fix bugs, or of course we do. All the security fixes are applied and so forth. But it's stable from an API point of view.
I see.
For instance, Python 2.7. Now, Python 3 goes out and people want to use version 3. You can't rip out the system Python and put a new version in because it's not compatible. Right? And so what we do is we provide a new version that installs in a separate location so developers can use it, but the sysadmin is not going to break all the scripts and all the tools and applications installed. So we find that balance. And for cloud developers, whether it's Java, Go, Node.js, we need to kind of keep up with the versions that are installed. And I think we've done a good job of that. And the thing we announced today was a developer VM in OCI, in Oracle Cloud. That's Oracle Linux 7, and it has all these things pre-installed. So you can push a button in the marketplace, and 3 minutes later you have a VM running that has all the libraries installed, the languages, the SDKs for Oracle Cloud, the instant client for the Oracle database, Terraform, everything. And so a developer can basically click a button and have everything they need to get going. Write tools and libraries and scripts that bring up Oracle Cloud infrastructure, can create an autonomous database, get the credentials, then create a Python or JavaScript that talks to the database and runs an app inside it and stuff like that. And so given the CI/CD DevOps model that people want to do, they need this. Right. And so I think we've given them a platform now that lets somebody really automate end-to-end, from infrastructure to application to test and development and production.
Right. Okay, Wim, thank you very much. Just one last question. What's next for you? Where do you go from here? Actually, you were in Dubai a few weeks ago, and now you're in here. What's next?
Go home.
Oh, you're going to go home. Well, that's good.
Talk to customers. Actually tomorrow, talk to lots of Linux customers, and then head back to San Francisco. But it's been a great event. Yeah,
it's been. I mean, the facilities here are beautiful. I keep on saying it, but it's actually, we only had one stream break here. We've done 25 interviews and only one's broken so far.
Okay.
So
great.
That's incredible.
Yeah.
And I think there's been a lot of energy out there too. A lot of conversations. Yes. The booths have been full.
Yeah.
And
it's been great. Yeah. So happy to have come here.
Great. Well, I'm sure I'll see you in San Francisco in the fall, in September for OpenWorld, and you code 1 as well. So, okay, guys, thank you very much. I think we have 1 or 2 more interviews here, so stay tuned. Thanks a lot. Bye-bye.